How do you calibrate an analog to digital converter for accuracy? Imagine trying to measure a tiny voltage change and getting a completely off reading. That's where calibration of an analog to digital converter comes into play. When you connect sensors or signals to your electronic system, the converter turns the analog voltage into a digital number. But these conversions can have errors. Calibration helps fix those errors so your digital output truly reflects the real analog input. First, you need to understand the types of errors that can happen. Offset error is a constant deviation added to all measurements, making everything seem higher or lower than it really is. Gain error affects the slope of the transfer function, causing the output to be scaled incorrectly. Nonlinearity errors mean the accuracy varies at different points along the input range, making some readings less precise than others. Knowing these errors helps you plan how to correct them. Next, you perform an initial calibration. Start by applying a known reference voltage to the ADC input. Usually, you use 0 volts or the lowest expected input for offset calibration. Then, apply a known full-scale voltage, which is the maximum input your system expects. Record the digital output codes for these reference points. To find the offset correction, subtract the measured 0 input output from the ideal 0 code. For gain correction, compare the measured full-scale output to the ideal full-scale code. These calculations give you the correction factors needed. Once you have these, you apply the corrections. Offset correction involves digitally subtracting the offset value from all subsequent ADC outputs. Gain correction scales the output to match the actual input range. These adjustments can be made in software or hardware, depending on your system design. Some ADCs have built-in calibration features that automatically perform offset and gain corrections. Others requiring manual calibration using external circuitry or algorithms. Calibration techniques can be analog or digital. Analog calibration involves adjusting internal reference voltages or current sources to reduce errors. Digital calibration uses algorithms to process the digital output and correct errors after conversion. Some systems use self-calibration functions that run automatically, while others need manual calibration during specific periods. Background calibration runs continuously in the background, keeping the accuracy stable without stopping data collection. Foreground calibration requires pausing normal operation to perform calibration steps. To keep your system accurate over time, periodic recalibration is essential. Changes in temperature or component aging can cause errors to drift. Continuous digital calibration can run in the background, especially in pipelined ADCs, correcting errors in real time. To improve measurement precision, take multiple readings of the reference voltage and average them out. This reduces noise and makes your calibration more reliable. Finally, calibration scheduling depends on your system's needs. Many systems perform initial calibration at power-up and then recalibrate periodically. Environmental factors like temperature fluctuations also influence how often you should recalibrate. Proper calibration ensures that your digital signals are faithful representations of the original analog inputs. This accuracy is vital in applications like medical devices, instrumentation, or communication systems, where precise measurements matter. In essence, calibration is a step-by-step process of measuring known references, calculating correction factors, applying those corrections, and maintaining accuracy through ongoing adjustments.